A warm welcome to Module 2 of our Polygon series. Today we will explore types of polygons from simple to complex. After this module, you will be able to analyze the properties of simple and complex polygons and also classify them accordingly. But before we dive in, let us quickly recap what we discussed in our previous session. Two-dimensional closed geometric figures with sides made of straight line segments only are called polygons. Which of these are polygons? Observe the options carefully. You may pause the video to answer. Well, we know closed two-dimensional shapes when drawn using line segments only are called polygons. Well, these conditions are satisfied by option A because it's a closed figure and drawn using line segments only, and option C because it is also a closed figure drawn using line segments only. Whereas option B is an open curve, option D is closed but is drawn using a combination of curve and line segments. So A and C are the polygons. Now that we know what polygons are, let us dig deeper. Let's take a polygon and reduce its number of sides and observe the interaction of the sides closely. I'm going to pull the sides of the polygon and stretch them to overlap or cross the other side. Observe the orange marker, which is highlighting the point of intersection. This pulling and stretching can also be experimented using a rubber band or a paper cutout. These polygons, which self-intersect, are called complex polygons. These polygons have sides that overlap, intersect or cross over each other. That is why these polygons are also called as complex polygons. Observe the orange markers to see the point of intersection. So this is a complex polygon on screen, and opposite of complex is simple. For example, the polygon that you see on the screen now is a simple polygon because it doesn't have any self-intersecting side. This again is a simple polygon. A simple polygon once again. Now let's overlap the side. Now you can see the point of intersection, and this is a complex polygon. Again, point of intersection and complex polygon. So we started from simple and moved to complex polygons. So simple polygon now turning into complex with 2 points of intersections. Now it is again simple, no point of intersection, and now point of intersection, and this is a complex polygon. So we can categorize polygons as simple and complex. While we are on the topic, we must address a common misconception. At times when the sides intersect each other, it so happens that one of the interior angle turns into reflex angle, which means more than 180 degrees, and that can be visually seen due to the dented shape. So sometimes simple polygons also have a reflex angle, and complex polygons might not have a reflex angle. So both the types, simple as well as complex, may or may not have an interior angle greater than 180 degree. So it is not a characteristic of complex polygon to have 180 degrees interior angle, and similarly it is not a characteristic of a simple polygon to not have a reflex angle. Both of them may or may not have. So you can see a reflex angle in the simple polygon and in the complex polygon as well. Have a look at the observation once again to see the transformation from non-intersecting, that is the simple polygons, which you see on the screen right now, transforming into complex polygons. These type of polygons formed important application in complex analysis and also differential geometry in higher classes. It is important to mention here, in some resources, while defining polygon, the term simple is also used. But generally, polygons can be simple as well as complex. Being simple is not a characteristic of a polygon. The only definition of a polygon is that it should be closed two-dimensional shape drawn using line segment. So, observe the two polygons on the screen. Can you observe the point of intersection? Yes, the sides cross over each other, and hence these are called self-intersecting or complex polygons. Whereas the three polygons that you see on the screen now, which you are familiar also with, these sides, their sides do not overlap, intersect each other, and such polygons are called simple polygons. Now is the time for us to practice together. Identify complex polygons. You may pause the video if you need more time to interact with the questions. The first one, do you see any side overlapping? No, that means it is not a complex polygon, it is a simple polygon. In the second one, we can observe the self-intersecting side, making it a complex or a self-intersecting polygon. Third is not a complex polygon. You may mention the reason in the comment section. And fourth one is indeed a complex polygon. Which of the following is a definition of simple polygon? A polygon that intersects itself. A polygon whose interior angles can never be greater than 180 degrees. A polygon whose boundary does not cross itself. A polygon that has all sides of equal length. When we read the term simple, the first thing that should come to our mind is non-self-intersecting. So the first option is cancelled because a polygon that intersects itself is not a simple polygon, it's a complex polygon. The second option, a polygon whose interior angles can never be greater than 180 degrees, which is not a definition of simple polygon. It may or may not have a reflex angle or an interior angle greater than 180 degrees. A polygon whose boundary does not cross itself. This is the only condition, only criteria which makes a simple polygon different from a complex polygon. And the fourth one, all sides of equal length. This is not a mandatory condition for a simple polygon because a simple polygon may happily have all sides unequal as well. Which of the following is not one of the characteristics of a complex polygon? It may have one interior angle greater than 180 degrees. Yes, it can have. It is not a definition, but it is a characteristic of a complex polygon to have one angle greater than 180 degrees. Its sides do not have gaps or openings. Well, this is a basic criteria for any shape to be a polygon. There shouldn't be any gaps, there shouldn't be any openings. It has to be a closed two-dimensional shape. It can be self-intersecting. Complex polygons are self-intersecting. They always have equal sides and angles. Do you think complex polygons always have equal sides and angles? So, we know the answer. The correct option is D. So, the key difference between simple and complex polygons lies in whether their sides intersect or not. Simple polygons, the sides do not intersect. Complex polygons, the sides intersect. Stay in the video till the end to dive into the rapid fire round and show off your math skills. I'm now leaving you with questions that will challenge your understanding. Put your pen to paper, music on or mute, whatever helps you focus. Take your time and let your math progress shine and reflect. I will see you in the next video to discover the types of polygons. Until then, keep learning, keep practicing and stay curious.